Doesn't this take up a lot of space?
No, once I put it on YouTube, I delete it off my phone.
Oh.
All right.
Wait,
What
why
is?
did you put it on YouTube? I don't want to be on YouTube.
It's too long to send it any other way because then it'll say that it exceeds the amount that I'm allowed to send.
Ah.
All right, chapter 4 was about equations and inequalities. So it was simple things like just solving equations, but they're going to give you unknowns on both sides. So now I can't see the whiteboard. Okay, that's better. So, for example, let's just get this nice and thin line. Let's say you had, sorry?
No, I'm just saying.
They might give you something like 6 times x plus 2 equals 4 times 9 minus x. They might give you something like that, right? Okay, so Sarah, how would you solve that?
Okay.
What would your first step be?
A time.
Good, your times. So we're going to times the 6 into there, right? And the 4 into there. So we're going to get 6x plus 12 equals 4 times 9 is 36 minus 4x. Happy with that?
Yes.
Now what do I do?
Now you cluster the 6. Wait, no. You cluster because it's not says it equals 4.
The equals is in between there, in between the two.
So must I figure out this side?
So you got to get the x's to this side, we've got to get the x's to this side here, and we've got to get all the numbers to the other side. So we've got to start moving stuff around. So how do we move that minus 4x?
Minus.
You plus.
Oh, I was looking at the other one.
So if we plus the 4x there, that cancels, right? But whatever we do on this side,
the other side.
So we're going to get 4x plus 6x is 10x, right? But we're also going to minus this 12 because we don't want that 12 this side. So we're going to minus 12 from the 36. What's 36 minus 12?
Wait. No. Wait, 22. 24.
24, well done. But we don't want 10x, do we? We want x by itself.
Yes.
So that's 10 times x. What's the opposite of times?
Divide.
So we divide that side by 10. 10 is gone. Divide this side by 10, and I get that x equals, what's 24 divided by 10?
Point. 4.
Can you do that on your own? Can I give you one to try?
Yes,
Okay.
yes.
You try this one. Let's say you've got that 0 equals 12 minus 2 in brackets y minus 3. See if you can do that one.
0. Okay. Why does this look different to the one we did?
It is different to the one you said.
I don't know what I did.
You don't know what you did. Okay. Whenever you see brackets,
Okay, this one.
what are we going to do?
I just did y3.
You just did what?
I just put y and 3 together.
No, you can't. They're not like terms. Brackets, you got to times. As soon as you see
You're
brackets,
glitching.
so we're going to times. We're timesing the minus 2 by everything in the brackets, right? So you're going to get 12 minus 2 times y
I
is.
didn't think of it that. I was thinking of them as two different things. I had to figure it out. Okay, wait. Let me retry. Hold on.
Right.
Wait. Okay, I got one.
Okay.
I got, for this little section here, the bracket, I
Mhm.
got 2y minus 6. Is that right?
No, plus 6.
What?
You
Oh,
got
yeah, because
it's a minus times a minus. Okay, so we at this level now, right? We've got to get all the y's onto this side and all the numbers onto the other side. So we're going to move this minus 2y. How do we do that? What's the opposite of minus?
that's plus, plus.
So if we plus 2y, that'll cancel, right? But whatever we do on the right, we have to do on the left. So 0 plus 2y is 2y, isn't it? What's 12 plus 6? Because these are like terms, we can add those. Good, 18. So 2 times something is 18. What do you have to multiply by 2 to get 18?
No.
So then y must equal 9.
Okay, give me one more.
One more. Let's go. One more time. I'm going to give you a hard one now. Now we're going to really stretch you, Sarah. We're going to give you 75 over n plus 5 equals 5. Ooh la la. I don't like this background. This background cuts my head off. Watch.
Yeah, I don't like that. They've changed that now. Uh, 75. Okay, I tried to do it a short way without having to do the whole.
A short way.
Yes, I was trying to figure out what 75 divided by 5.
That's a good idea. Yes. So 75 divided by something. So you said if I divided 70 by something, what do it have to be to give me 5? What did you get?
50.
75 divided by 15.
50.
Good. So then your n plus 5 has to equal 15, right?
Yeah.
So if something plus 5 is 15, what is that something?
Okay.
I like your shortcut method. It works.
Yeah.
So stick with that. Yeah, you looked at if that was just one whole number at the bottom, what do you divide 75 by? You divide it by 15. So the n plus 5 must be 15, and then n must be 10. Well done,
Yes.
Sarah Pereira.
Yay!
Look you, clever. What about simultaneous equations? Oh la la, what do we do with those?
Ooh, now.
So let's say I had, if I gave you that x plus y equals 26 and x minus y equals 12. I want to know what x is and I want to know what y is. How would you solve that?
$40. Well, wait. No, it's not. No, wait. Hold on. Okay.
We're going to call that equation 1 and we're going to
Hold
call
on.
that equation 2. I'm holding on. I'm just giving you numbers for the equations.
How's that? Wait, no, it is. It's 14.
Which one's 14, the x or
And
the
that
y?
wouldn't make sense because x minus y.
Do you remember the elimination method? Where we've got to eliminate one of the variables. So you've got a plus y and you've got a minus y. If I add them, if I said equation 1 plus equation 2, let's see what happens. So I'm going to take the x plus y equals 26, my equation 1, plus x minus y equals 12. And I'm adding them, right? So x plus x is 2x. Happy with that? Plus y plus minus y is the same as y minus y. Cancels the y's out. And 26 plus 12, so x and 2 is 8. 2 and 1 is 3. So 2x equals 38. So 2 times something is 38. What do I have to multiply by 2 to get 38? I'll tell you, I can divide both of these by 2. The 2's cancel.
19.
Good. X equals 19. Now that I've got x equal to 19, I'm now going to substitute that 19 into either equation 1 or equation 2. Which one would you rather me substitute it into?
Equation.
Okay, so let's do equation 2. So we're going to put this into equation 2. That's that one over there. So instead of x minus y, I'm going to put 19 minus y equals 12, right? So I took the x out and I put the 19 in its place. Now, if I take the 19 across, I've got to subtract 19 on this side. Cancels that out. I've also got to subtract 19 that side. So minus y equals 12 minus 19, which is minus 7. And if minus y is minus 7, then positive y is just 7. Make sense?
I don't. No, not really. I don't get that whole cancelling out.
Okay, your elimination method. So let's look at another example. Are you ready?
Yeah.
If I said that y equals 2x minus 1 and y equals x plus 4. I've got two equations, right? I want to solve them simultaneously. So what I'm going to do is I'm going to say, all right, well, let's just look at these. I've got a y and a y. Now, when both of them are positive, that's equation 1, that's equation 2. Because both of my y's are positive, where on the previous one of my y's was positive, one was negative, that's why I added them. This one, they both have a positive value. So now I'm going to subtract. I'm going to say equation 1 minus equation 2. And I can do that because the y's both have a coefficient of 1. It's both just a single y. So I'm going to say y equals 2x minus 1. Subtract y equals x plus 4. So I'm subtracting the whole of equation 2 from equation 1. Y minus y is 0 because they both have the same value. So y minus y is 0. So I get 0 equals 2x minus x is just going to be x minus 1 minus 4. So I started at minus 1 and I'm going even further minus, will be minus 5, right? Now if something minus 5 is 0, what is the something?
If something minus 5 is 0.
Yes.
5.
Good. X must be 5. But in simultaneous equations, once I've got either the x or the y, I've only done half the equation. I haven't done the whole equation. So I've now got to take this and substitute it back into one of these equations. I'm going to use equation 2 again. And I'm going to say then y equals, instead of an x, I take the x out, 5 plus 4. What is 5 plus 4?
It is 9.
There we go. Y equals 9. X equals 5, y equals 9.
Okay, you're gonna have to give me one of these to figure it out, because I have to do minus.
Okay, I'm going to give you one to try.
I'm a, what do you call it? Tactile learner. This is do something.
Great. Tactile learner. Let's give you something to do. Okay, so you've seen me do 2 now. I've done the one where the y's had different values. I've done all different signs, should I say, where I added the 2 equations. So I just took equation 1, equation 2, added them. And because both of those y's were positive, I subtracted. So I want you now to take this one. Y equals x plus 9. And y equals 3x plus 1. Solve that simultaneously.
Okay.
Okay, while you're doing that, I'm just going to go quickly get a drink of water. You're on your own now.
Okay. 14.
14.
I know I'm wrong, but I don't know. I was trying to do it on my own.
I'm proud of you for trying to do it on your own. So you had equation 1 and 2, right? The y's again, both are positive, right? So I'm still going to subtract them. I'm going to say y equals x plus 9, the first equation, minus y equals 3x plus 1. And I do line my y's up underneath each other, line the x's up next underneath each other, line the constants up next to each other. Y minus y is 0, right? X minus 3x is minus 2x. 9 minus 1 is 8. Happy with that? Bringing the 2x over to this side, I get that 2x equals 8. So I brought the 2x over, changed it to positive. Okay? Happy with that? And then 2 times the number is 8. The number must be 4. Happy with that? I'm now going to take that 4 and stick it into either one of the two equations. It doesn't matter which one. I'm just going to choose this equation 2. So y, and you could have put it into equation 1. It really doesn't matter which one you use. So y equals 3 times 4. So I replace the x with a 4 plus 1. 3 times 4 is 12 plus 1. So then y equals 13. So I have my y and I have my x.
That's kind of what I did. Okay. Give me another one. Hold on. Wait, let me look at this for a bit.
Okay, look at that for a bit. Let it sink in.
Where did the got rid of? Okay. Okay.
You think you got it?
Yeah.
Alrighty, Sarah's turn. So, y equals 9 minus 2x. But y also equals x minus 12. Tell me when you've got it written down.
Okay.
You got it down?
Yes.
Then I'm going to leave this one on the screen so that if you want to refer back, you can.
So when I'm eliminating, do I do it from the same side that I eliminate?
Explain.
Like say, I eliminate 12. So I eliminate 2 minus 2.
Oh no, you don't want to eliminate the 12. You want to eliminate either the y's or the x's. Now remember, you've got to line them up underneath each other. These ones are on purpose, not lined up underneath each other. So if you put them underneath each other, you're going to have to move your x's around, aren't you? Well, you don't have to move them around. You just have to remember that you can only subtract x's from x's and numbers from numbers and y's from y's.
I have no idea what. Okay, let me show you what I've done.
Okay, show me what you've done.
It's not clicking in my head. So I wrote it down and then I said x12 minus 2 minus x. No, wait, 12x minus 2x.
You did 12x minus 2x. Sarah, it's not clicking in your head.
No, it's not.
Okay, so what I'm going to do is I'm going to swap these two chaps around so that we get the x in front, right? So I'm going to make this y equals minus 2x plus 9 rather. Then when I put them underneath each other, then when I subtract this guy, they'll be underneath each other. So I'll go y equals x minus 12. See that? Now my x's are in line, aren't they? Now I've got my x's underneath each other. I've got my constants underneath each other, and I've got my y's underneath each other. Now I'm going to do some eliminating. So I'm going to subtract the whole bottom from the whole top. So I'm going to take this y, subtract it from that y minus y is just 0. See, I've eliminated the y's, they're gone. We took them out. We got a gun and we shot them. Bang. Okay. Then we've got the minus 2x, because that's a negative 2x, minus another x will give me minus 3x. Don't worry, the minus will sort itself out when we take it over. And then I've got a 9 minus minus. Well, a minus and a minus makes a plus, right? So 9 plus 12 will be plus, what's 9 plus 12? That's 21, isn't it? Then I'm going to take the minus 3x over to that side, make it plus 3x equals 21, and then divide both sides by 3, or ask yourself, what is 3 times what is 21? Well, I know 3 times 7 is 21, so then x has to be 7. Once I have my x, what do I do with it? Substitute it into one of the equations. So then y equals, I take the x out, put a 7 there, minus 12. And 7 minus 12 is minus 5. Done. Now, Sarah,
You're gonna have to send me some seriously.
I'm going to send you a YouTube video on this. But what you also have to know, you have to know by substitution and by graphics. And there's not a lot of time left, so I'm going to just quickly show you substitution method. This same one, I'm going to do the exact same one. With the y equals 9 minus 2x, and y equals x minus 12. Y equals this, right? But y also equals this. So then by substitution, I replace a 9 with the whole expression. So this is the substitution method. Substitution. Okay, like when you have a substitution teacher. So instead of y equals x minus 12, I'm going to say 9 minus 2x equals x minus 12. Well, now I've got to get all my x's one side, all my numbers on the other side. So I'm going to bring this x over by saying minus x on that side. And I'm going to bring this 9 over by saying minus 9 on that side. And I'll get minus 2x minus x equals minus 12 minus 9. Minus 2 minus 1 is minus 3x equals minus 21. And what would I have to multiply minus 3 by to get minus 21?
7.
Is that what we got earlier? Oh, look. And now that I've got that, I then substitute the x back into there, and I do the same as I did before. So I'll say that y equals 7 minus 12, which is minus 5. So the substitution method, you get either y equals an expression, and you make that whole expression equal to the y. So I replaced this y with this whole expression. So I just said we'll take the y out, we'll put the expression in the y's place. Or you could get everything in terms of x and then substitute the x out. It's up to you which one you substitute. This one was easier to substitute the y's because it was already in the form y equals something. Then graphical, the last method. graphical. This is where you have to draw a graph to solve it. Okay, so I'm going to do the same two graphs. Y equals 9 minus 2x and y equals x minus 12. We're going to do graphically now. Now we already know that the x should be 7 and the y should be minus 5, right? But let's see what happens. So I'm going to do a graph. I'm going to do my graph rough. You would have to do yours on square paper, otherwise it's going to be nearly impossible. I'm going to do the first graph blue.
So you're going to put something like this in the text, right?
Oh yeah.
I don't print my papers though, unless I like draw a graph.
Oh no. Do you have square paper?
I can use my math book.
Yeah, use your math book. Right. So if y equals 0, then I'd say 0 equals 9 minus 2x, right? Bring the 2x over. 2x equals 9. Divide both sides by 2, x equals 4.5. So on this particular graph, on this one, when y is 0, x is 4.5. 1, 2, 3, 4, 5. Okay, so 4.5, somewhere in the middle there. So that's your 4.5 on the x-axis. If x equals 0, then y equals 9 minus 2 times 0. And 2 times 0 is just 0, so y equals 9. Oh, I should have made this a lot longer. Anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's up there. All right. And then your graph would run down like that. Happy?
Yeah.
Okay, and that is the graph of, or graph number 1, we'll just call it graph 1. The next graph I'm going to do in red.
Yay!
Yay! Now with this one, if y equals 0, 0 equals x minus 12. Take your 12 over. So I'm going to take the 12 over the sum because it is already negative. And 12 equals x. Oh sure, but that's like down, way down. Okay, pretend that's 12. I can't get my 12 on. And then if x equals 0, then y equals 0 minus 12. So y just equals minus 12. So now I'm going to come way down here somewhere. And I'm going to say that's minus 12 on my axis. And I'm going to take a line through the two 12s. And that will cut at a point. And that point will be the point. Let me just do a different color now. We're going to do orange. That point over there where the two graphs cross, that'll be the point 7 minus 5. Because remember, your x has to be 7, your y has to be minus 5. And that's how you solve them graphically. You let each of the unknowns, the variables, be 0 first to get your intercepts. Draw the graph through the two different intercepts, and then you'll have your two straight lines. So first I let the y equal 0, replace the y with a 0, solve for x, then replace the x with a 0, solve for y, get your two intercepts, your x and your y intercept, and then do the same for the other one.
I'm going to have to study hard.
Yeah, because we've only managed to get through your simultaneous equations today. Okay. Inequalities work exactly like an equation. You just solve your inequality the same way you would an equation. You also have to do inequalities on a number line. Remember, if I have a number line, and,
oh yes, I remember this.
And you've got your, let's just say you've got, let's say that's minus 3, and let's say that's 10, and you've got a circle there, and you've got a colored in spot there. It means the minus 3 is not included, the 10 is. So you'd say your x is bigger than minus 3. You can't put a line underneath because it's a hollow dot. but it's less than or equal to 10 because 10's colored in, so it's got a less than or equal to. Number lines are good fun. Chapter 5 is angles. Do you remember your angles? Interior and exterior angles of a polygon. You had to remember your...
We'll also have I'll study these. We'll also have our lesson on... Oh yeah, we won't. Wait, no we won't.
On Thursday?
Wait.
Aren't you, when is our next lesson?
It's on
Wednesday. What day are you flying?
Tomorrow.
Okay, so you'll already be in Lisbon on Wednesday. So how long is the
But
flight?
I'm not doing any lessons on Wednesday because I'm going to be settling down and driving and stuff. And it's I don't know, because it's a 3.5-hour flight to Angola, and then I think I arrive in Lisbon I leave at 11:30 at night from Angola, and I arrive in Lisbon at 6 in the morning.
There's plenty of time then. You can sleep on the plane, and then
Okay, yeah.
and then you
But
can,
no, I'm not doing the
and then you can do your maths,
No.
and then you can do your maths because by
I'll
then.
do it on Monday, okay? I'll make sure to do my work and study, but I'm not doing it
But if
until
it's
I arrive.
2:30 in the afternoon here, it'll only be 12:30 in Lisbon. You'll have plenty of time to sleep and
No,
catch
I'm
it.
gonna go out and see the place and everything.
What did you see in Lisbon? You said it's going to be cold and miserable.
No.
So you're going to go and look at cold and miserable Lisbon instead of doing maths. No, that's fine, eh?
I
Yeah.
would rather do that. Okay.
Alrighty. Well, I'll send you some YouTube videos to watch.
Okay.
Just so that you can, because I mean, you're going to get bored in Lisbon anyway. You're going to go out, you're going to see Lisbon as cold, wet, and miserable, and you're going to think, oh, no, this is boring. I need to do something. And you're going to, oh, yes. Daryl, send me some math videos.
I'm only going to the airport in Lisbon. I'm staying in Sintra, which is another city there. Well,
So that'll be even smaller than Lisbon. There'll be even less to see.
yes. But
So
it's
then-
fine. I like it.
5 minutes, you've seen the whole village, and then you can do some maths.
Yes.
Cool. Alright,
Okay.
alright, sir. You have a safe trip.
I'll try.
Alright, tell
Have
that
a good day.
pilot he better fly carefully. See, he's got precious cargo on board. Alright,
Bye.
see you, sir.